This video is a continuation of the previous video where we implemented the stacks as an array. In this video, we'll implement a stack as a linked list. Let's get started. What we're going to do is we're going to take the project where we implement the stack as an array, and this time we're going to edit the implementation files. See, that's the benefit of using an abstract data type, is that you can change the implementation without affecting the client. And that's what we're going to do in this video. So what we're going to do is we're going to copy. I'm going to copy the, I'm going to create a new folder. Okay, I'm going to say stack as linked list. Okay, and what I want to do is I'm going to copy all of the files. Okay, I'm going to copy all of I want to copy the header, the main, this is the client, the implementation files I'm going to edit, and the interface. So I'm going to copy all of these files over to this folder. Okay, so let's paste them in. And then now what we're going to do is we're going to open up Visual Studio. Okay, we're going to create a new project, but we're going to create it in that folder. So it's going to be a console application. Next, I'm just going to call it stack as linked list. How's that? And I'm going to put it into, not stack as array, but I'm going to put it into stack as linked list. Now, why does it not find it? Let's refresh, see if it's, should be there. Okay, let's close this and see if we can get it again. It's stack as linked list. Let me refresh here. Stack as linked list. Maybe there's something in my oh, here it is. I was in the wrong folder. Stack as linked list. Select that folder and go create. I'm going to place the solution in that directory. And so it's going to create a source file. Okay, and we're just going to move it to that location. So this stack as linked list.cpp, I'm going to delete this, but I'm going to copy my main and everything in here into this folder. So you see here we have stack as linked list.cpp. That's the main, that's the client. I'm going to get rid of that. So I'm going to go here, say cut, and paste it here. Okay, and then I'm going to get rid of this one that was created, the stack as linked list. So let's do that. So in here, let's make this larger, and I remove this one and delete it completely. Okay, and here I'm going to copy in all of the header files, so item.h and stack.h, add those, and I want to add in all of the C or CPP files here. So let's go existing item. I don't want to change main. I want to use the client as is, but I want to change how we implement a stack. So I'm going to have stack.cpp. I'm going to change all of these functions, and I'm going to have stack.h. Okay, the interface shouldn't really change. I might add a function or two, but in order to implement this, I don't want to change the client. Okay, I want to be able to use. So this is the client. I have all these different examples here that I can use. Example 1, 2, 3. I want to be able to show all of these examples. I'll start with the first one. I want to be able to show all these examples, okay? And I want to be able to use the linked list based stack rather than an array based stack. Okay, so what do I have to do? Well, the first thing I have to do in item here, item.h, whenever I define a linked list, okay, I define a node structure, right? A node contains an item and a pointer to the next node. So what I need to do now is I need to define how the item is stored in the node and what the node structure looks like. Okay, so what I'm going to do is first I need to define what a node looks like in the stack. Okay, so we have struct, right? I'll call it stack node. Okay, and what does it look like? I mean, it looks like we have an item. We call item, and we have a link, which I haven't yet defined, uh, to the next node. Now, how do I define a link? Well, what I do, I can define it anywhere, but I'll put my type defs here. Type def struct stack node pointer, okay, is a link. So a link is an alias. So this name, this data type, link, is an alias for a pointer, right, to a struct stack node data type, which we defined a struct stack node data type here as containing an item and a pointer to a struct stack node, right? A link. Okay, so that's how this works. So I have my my item, which I can now include. Item.h can now be included in those other files. So all I'm doing, I might add a couple of functions or things in order to implement the linked list, but I can still use my main from before. Okay, the client doesn't see any changes. All right, so what do we do next? Well, next we have to define our stack.h. Okay, so what do we have? We have init stack. Okay, that shouldn't change because we're going to be using this function in client. Is stack empty? Doesn't change. Void stack push doesn't change. Or sorry, stack push doesn't change, and stack pop does not change. The only thing that we might want to add here is the ability to create nodes. Okay, so what I'm going to do is I have a link, and then I have this new function, and what it does is it takes an item as an input, and it takes the pointer to the next node. Okay, so it's creating, so whenever an item, a new node is created, because now we're using nodes, we're going to put an item inside the node, and this node has the link, or this next variable, can point to the next node. Now remember, a stack, we push and pop to the head. Okay, so that's it. Our interface only required this new additional function, but the client doesn't even use this function, so the client's not going to see any changes. So Control C, let's go to stack.cpp, and what we need to do is we need to define these. So this function, or this file can change. Okay, so this file is the implementation, but the client doesn't see this. The client only sees stack.h. Okay, so we have to go. Item.h is basically done. Main is never going to change. Stack.h, we're basically done. Once I define this, the green line will line will go. Okay, so take out that semicolon, replace it with curly braces, and we are off to the races. Okay, so we have our function. So here we have, instead of working directly with the items, okay, in the implementation that uses a linked list, we don't have these are not variables that we are going to use. What we care about is the nodes themselves, right? The nodes that are used in the linked list. So what we have is, okay, we're going to restrict it to this file, this variable, a pointer to the head of the linked list, right? That's the top of the stack, right? So this is pointer, or we could say head of linked list, right? Which is top of stack, right? Or the head of the stack, if you like. Okay. Okay. So this guy points to the stack all the time. He's private. The client doesn't see this, right? The client cannot access this. All right. So the new function was provided. All we're doing is we're making room for a new node, and we're adding it onto the. We're returning the newly created node. Okay. So we have link x equals link, okay, malloc, and size of right? And then we have a stack node. Okay, so every time we make a new node, okay, and this just allocates space for the node, okay, and then we have to place the item, right, into the node, right? So we say x, what x is pointing to, right? So x is a pointer, right? It's a pointer to a node. What it's pointing to, its item, right? The item equals item. So here we're storing the item in the node, right? Okay. Remember, this means x is a pointer. This means dereference it. What it's pointing to, its item. And here we're going to store item right inside. Okay. And then we also have, as part of a node, we have the next pointer, right? So x has a next variable, and we got to set this. We got to make it point to something, and we're going to point it to next. Next is provided when you create the new node. Basically, this is going to be the previous head, right? This is going to be the previous head of. So we're going to make new node point to previous head. Effectively, that's what we're going to do, okay? Which is passed in next, okay? And then we return x. So this is we're passing a pointer, right? Pointer to a node, a stack node, and we return it. Okay, perfect. Now we have our init stack, okay? And our init stack, again, we don't even need to pass a max n. We don't have to pass anything here. All this does, and you can keep the same input, but it's not going to use it here. All we're going to do here is set head equal to null. Okay, this is how we initialize the stack. And we don't have an array, we just initializes the stack. It's empty. It's an empty stack. Okay. All right, now, why head equals null? Head can only be accessed by this function, right? Or the functions in this file, because it's static. It's a global variable, but then static means restricted to this particular file. All right, check if the stack is empty. Here we return, instead of the ISP equals 0, we return if the head equals null. Okay, right? Because it's empty when it's null. If it's pointing to something, that means it's not empty. Okay, so this checks to see if the stack is empty, right? Because it's null when empty. Head equals when stack is empty. Okay, that's basically the main point. Okay, and then stack push and stack pop are, well, stack push is just create a new item, right? So stack push is actually really simple. It's head is equal to new. We use the new function, item, and we pass the previous head, right? Because it's going to be the new head, right? So head, the new head, is this new item that we're going to return. This returns a pointer to a node. We pass the previous head, right? And we put the item in the new node. We make the it point to the previous head, and then we make the head, this new item, the head. That's it. It's that simple. So here, what I could say is the new item, or new node, right, containing item, is pushed to head or top of the stack. Okay, and then stack pop, it's a little more complicated, but what we're doing is the new head is going to be the item after the current head. Okay, so that's what we have to do. We have to reset that. So what we're going to do is we need a temporary variable in order to do that. So we say item item, okay, this is what's going to be returned, equals what's at the head and then item. Okay, the item stored at the head, right? This grabs what's at the head, right? So store the current item at the head. Store item at head in temp variable. This is what will be returned. Okay, and then we also have to store what it points to. So link t, this is going to be the new head, right? Head, so the head, what the head points to, the next pointer. So it's basically head, it's next, there's a pointer called next. It points to the next item in the linked list. And so we got to store that, excuse me, we got to store that somewhere. Store, right? Next head, right? This is the next head in T. It's the next item in the linked list. Okay? So the next item in the linked list is going to become the new head, or let's say new head in T. Okay? And then we can now free the head. So free the what's stored in the head, right? But we saved everything in item and T, right? Remove node at head of linked list. Okay, and then head, we set head to be T, the next, right? This is next node becomes head. Okay, and then we return the item that was at the previous head, right? This is return item at the head when we open this function, right? At previous head, top of stack. Okay. Okay, that's the one that we wanted, right? This is currently at the stack. We need to return it, and that's it. We have now Control S to save. We have now implemented. Okay, we've changed our implementation. Instead of as an array, we're doing it as a linked list. Now there might be an error somewhere. Item equals item. Let's see. What's it telling me? Dereferencing a null pointer. Let's just see. Let's see. Do I have any? This is a warning. It's not a dereferencing a null pointer x. Oh, because I haven't allocated anything yet. It will. It'll get allocated right now, right here. Okay, let's run it, and this should go away. So let's test, and let's see if it will reverse. If it gives us no errors. Okay, how many items would you like to push to the stack and reverse? I don't know. Let's go with 7. All right. So, hi, how are you today? I am. Okay. So, hi, how are you today? I am. So it's reversed. So no issues, and everything works as we saw before. We can also run in main here. We can also run the other 2 examples. And again, it's your job to combine example 2 and example 3. But here in example 2, we're converting infix to postfix. So we're going to convert this. This should evaluate to 35. Let's check to see that our code. Actually, sorry, this converts infix to postfix. So 20, we had it written as 20 plus 15, and it converted to 20, 15 plus. So it's in postfix. And in example 3, we're going to evaluate that expression. So let me go here and comment this one out. Control S and run, and we should evaluate. It should evaluate to 35, which it does. Okay, I hope you enjoyed this video. Again, this is the power of using an abstract data type where you can change the implementation without having to affect how the client uses your data type.